Bharat Mata ki Jai. So we are going to start chapter motion. So I'm welcoming you each and everyone in EduUniverse channel. So I think you are in great Josh. All my class 9 student, okay, all my colleagues. Let's start with a great Josh, and we'll complete each and every topic of chapter motion. Before we start our chapter, let's go in a motivational thought. Okay, life is just like a motion, and yeah, everyone know you need to start motion. Yeah, life is just like a motion. If you stop, okay, if you stop moving, if you stop moving, you will stop growing. And it is very very correct, because see, when you are preparing for your exam, preparing for your ninth board exam, if you stop that preparation, oh my god, and that time will lose your confidence and you will start growing and your achievement will decrease. Okay, so let us start with a great Josh chapter motion. Okay, so now can you tell me what is motion? Okay, can you tell me what is motion briefly? Okay, so okay, what is motion? What do you understand by term motion? Motion is nothing but, motion is change in position of an object or a body within a time. Okay, motion is a motion. Okay, I'll write motion is a change of body, or you can say object, with time. You think that motion is must for our human being? See, yeah, motion is very very important, because we cannot do anything, we cannot do any work without motion, isn't it? So what is motion? Motion is a change of body uh, or object with respect to time. See, now I am writing, I'm doing a motion. Okay, you are writing notes, it's a motion. Okay, you are doing your work, is motion. And motion is, you know motion are used and motion are being done, and without motion we cannot do anything, means day-to-day work. Okay, so continue with motion. For example, see, example I've showed you that walking, talking, dancing, all action are motion. After motion we will look after what is distance. Okay, what is distance? What is distance? What is distance? Can you think? Can you tell me what is distance? What is distance? Distance is nothing but, distance is nothing but the length, the actual length from where you travel. Okay, the actual length, you can say actual length, length, actual length. Okay, means, see, this is our school. Okay, and this is our house, and this is all is jungles, all the jungles over here, and our road is through like this. Okay, and over here some buildings you can show. Okay. So if this is a school, okay, and this is our house, what is distance? Distance is actual length. Actual length means the length you travel from your house to the school, or from the school to the house, to the visitors. Okay, so you travel from all the way like this, and you come to school. This is the actual length, means the length you travel. Okay, actually, okay, this is known as distance. The distance you travel. Okay, the distance you travel from home to your house, to your house to your school. Okay, and now we will discuss on displacement. Okay, displacement. Let's see what is displacement. Displacement. Displacement is a shortest distance. Okay, it is the shortest distance from initial from initial point to the final point, or we can say initial point to the final point is known as displacement. For example, you can take same example, your school, your house, okay, and school area. So this is a I in which I've past figure, which I'm sure to you is like this, in which we travel the distance, we go all the way traveling all the road from the school, looking each other traveling, and what is it? Displacement. This is not a distance, okay? Distance, and displacement is the shortest path from the school to the house, in which we cannot travel, but it is a shortest distance, because here there was jungle. How we can travel in the jungle to the school? So it is shortest distance, which can imaginary. It is imaginary shortest distance. Okay, it is known as displacement. So we will take some examples of. Okay, before example, we will discuss some types of motion. Okay, uniform motion. Okay, and there is another non-uniform motion. Okay. Okay. So what is uniform motion and non-uniform motion? Uniform motion is a motion which is traveled in equal distance or distance in equal interval of time. Interval of time. Okay, equal distance in equal interval of time. Okay, the moment is known as uniform motion, and non-uniform motion is a motion which travel in unequal distance in equal interval of time. Okay, so you can take for example of for uniform motion of pendulum, because it travel pendulum equal distance in equal interval of time. And you can take also, okay, you can take also the clock, which travel, okay, equal distance equal interval of time. And for non-uniform motion, you can take example of common example, which is bouncing ball. Of ball. These are the examples of, we can example of pendulum, and clock are the example of uniform motion, and bouncing ball is known as non-uniform motion. Okay, so now we are going to see and learn the speed. What is speed? Okay, what is speed? Many a time we have, we have identified, or we have listened the term speed while traveling in car. See, when we're traveling in a car, we ask our father, uh, Dada, what speed now? Isn't it? Okay, so what is speed? What is speed? So speed is nothing but the distance traveled by an object in interval of time. Well, of time. Well, see, when we are discussing about the school, and you can say anything, market, the house, the distance, the particular distance we travel all the way from a house, the particular distance we travel from all the way from a house to the market, or to the market from the house in a particular interval of time, isn't it? We travel it is in a certain time, and the distance in meters, that known as distance upon time, is a formula for speed. Okay, so you can say speed is known as distance upon time, means the time is taken to cover a certain distance of time, certain distance, the time is taken to cover a certain distance is known as speed. So uh, and as in SI unit, okay, so speed we write as, we write as per meter per second, or meter second 1 minus in on inverse. We have discussed now what is speed, the distance traveled by an object in a certain interval of time from a house to whatever example is given. Now we will discuss what is an average speed. Okay, what is an average speed? What is average speed? Average speed. What is average speed? You can think on it. Can I think? The total distance. Okay, the total distance upon total interval of time is known as average. Total distance. Okay, distance distance upon total time taken. Total time taken. Total distance, total time taken. Distance is written in meters, and time taken is written as s in seconds. Okay. Time is written as second. So we can write as same formula here. Okay. So we have understood what is speed. Now we will look in what is velocity. Okay. What is a velocity? Velocity is nothing but velocity is nothing but uh, the displacement traveled by an object in particular interval of time is known as velocity. See, we know that the distance and this is displacement. Okay, distance upon displacement. Okay, this is distance and this is displacement. So the shortest distance is known as displacement. So displacement by time is known as velocity. Displacement upon time is velocity. So velocity is equal to displacement by time. Okay, what is time we taken to cover a displacement? Velocity. And velocity displacement is written in meters only, and time is written in seconds. So maybe meter per second, or ms, or ms. Now we will discuss. Now we will discuss what is velocity. See guys, we will do questions at the end of a chapter, because we will get to know what is acceleration, what is momentum, what is velocity, what is speed, and we will find very easy to encounter the questions, fight against questions. Okay, so now we will discuss what is acceleration. Okay. So now we will see what is acceleration. What is acceleration? Acceleration, the term acceleration. Acceleration means the rate of changing a velocity. Change in velocity. We can simply say change. Okay, change in velocity. Change in velocity. See, just imagine and just okay. When a car is moving in a certain velocity and in between it changes velocity. For example, it move from 50 kilometer per hour speed to 60. It increases from previous, from initial to the final, from initial to the final. See, for example, if you take uh, a ball moving on the diary, see, for example, this ball moving in a certain velocity. Okay, this ball is moving in a certain velocity. If we change, if the ball change its velocity, for example, it's moving and unfortunately it move in a high speed. In that case, acceleration takes place. Due to the acceleration, it move a certain distance. It increases or it decreases the velocity. The change took in that velocity. For example, while we are traveling in a car, when you're traveling in a car, we need to see we need to go fast. We need to go fast means we have to change our speed. Okay, and changing our speed is known as acceleration. So for example, we are traveling in a car and we want to go fast. So what we do, we accelerate our engine, we accelerate our car, and due to that acceleration, the change in the change in the vehicle, the change in the movement take place. For example, we can write as uh, final velocity. See, velocity can be written as v, and initial velocity can be written as u. Change means final minus initial, isn't it? Okay, so we can write here acceleration is equal to final uh, final velocity or a velocity minus initial by per unit of time, because the change took place in a time, no, in a certain time it took change, the change took place. That is why the formula of acceleration is a is equal to v minus u upon t. We can also write because the velocity and this velocity, see, initial velocity and final velocity, we can write as it's a velocity. Okay, we can write as it's a velocity, no, so we can write over here v upon t, and v is velocity meter per second upon second, t is time, and is equal to m s minus 2. This is an SI unit of acceleration. Once again, acceleration is nothing but the change takes place in a velocity. Change takes place in a velocity known as acceleration. So till now we have learned what is distance. Distance is what is the distance? The actual length. What is displacement? The shortest distance. What is speed? The distance upon time. What is velocity? Displacement upon time. And acceleration, change in velocity means you can it's changing a velocity in per unit of time. Okay, now we will look after the uh, distance time graph of class 9. For example, if we take okay, if we take length or length in x-axis or time in y-axis. Okay. So to find a uniform motion, the graph of uniform motion, will be uniform graph. Will be uniform because the its length or a distance and over here you can see time 5 10 I think 15 16. The graph will be always uniform because what was the definition of uniform motion? The motion takes place in a fixed length, fixed distance upon fixed interval of time is known as uniform motion, and graph will be always uniform. Okay, so we will now going to see the derivation of uh, all three laws of motion. So now we will going to see all the derivations not in integration and differentiation way but in a simple way for class 9. So the three laws of three motions are three equations of motion are: first equation is v is equal to u plus at. U plus at. We all know that acceleration is equal to, see now derivation from here, okay? Derivation is from here equal to, let's take acceleration, okay? Acceleration, take now we are going to see second equation of motion is equal to s is equal to ut plus half at square. Okay, we all know that average velocity is equal to final plus initial by 2. Okay, in which v is equal to velocity. Okay, velocity u is equal to initial velocity u and v. T is time, s is distance, and E is acceleration. So now to derive this particular formula, we know that velocity is equal to distance upon time, and distance will be equal to multiplied by time, because time and time will cancel, we left with distance. So now we take S is equal to velocity, which velocity is v minus u, v plus u upon 2 multiplied by t. This is multiplied by, in which S is equal to v, we can write as u. We have to use the first formula, first equation of motion. V is equal to u plus at plus u upon 2 will be multiplied by t. Okay, u and u, so there are 2u plus at upon 2 multiplied by t. So now t get multiplied with 2, the 2 ut plus at square by s. Okay, s is equal to 2 ut plus at square by. We can write as 2 ut by 2 plus at square by 2. 2 and 2 get cancelled, and s is equal to ut plus at square by 2, which is written as ut plus 1 by 2 at square. Add here that ut plus half at square, in which we finally derived formula s is equal to ut plus half at square. Okay, so we'll go to next one, which is third equation of motion. Derivation of third equation of motion. So now we are going to see third equation of motion, which is 2as is equal to v square minus u square, in which v is equal to ut plus at, we know that, and v minus u will be equal to at, and v minus u by a is equal to t. So we found the value of t over here. Okay. We have to simplify this equation in equation number 2, which is s is equal to ut plus half at square. Okay. So u multiply by t is minus u upon a plus half v minus u upon a square by a. Okay, after that we should multiply whole equation, which is vu minus u square upon a plus half multiply by a square minus a square minus b square the whole square, which is v square minus 2 vu plus u square upon a square multiply by a. uv square minus u square upon a will be plus this a and a will get cancelled, so only a will be left over here, and the 2 will be multiplied, this 2 will be multiplied with a, so 2a and v square minus 2 vu plus v square. Okay, which is equal to s over here. If we find the LCM of this, which is 2a by a, which is a is equal to 2 and this is 1 and 2. Okay, so 2a is answer. Okay, here 2a and uv minus v square minus plus u square and this plus u square and minus u square get cancelled, which we found uv plus v square minus 2 uv upon 2a is equal to s. Over here 2as is equal to plus v square minus 2 vu
Okay, which is uh, if we minus this with this, we find v square minus u square. Okay, and will be equal to 2as. This is a solution.